class, I was asked a couple of questions on homework 7 and homework 8. Homework 7, I believe they asked me for question number 4, question number 14. I'll help you as far as I can. I'm not going to do the calculations for you. The answers are there, but I will lead you to it. So, you have question number 4. We're looking for volume of these things, right? First, you identify what the bases are. The bases are always the two similar objects. So, if I look at number 4, I see this trapezoid and that trapezoid. Both of them match. Those are my bases. That means that the distance between them, that distance is my height of the trapezoid. Okay? So that will be, hold on, let's put this is your H. So now, all you need, because you have your formula of this prism, your formula, I'll put it up here, is big B, which is your base area, excuse my handwriting, I'm trying to write with one of these pens, times the height of the prism. We have it. So all that's missing is this guy, the base area. Well, we found out who the bases are. We found out that they're trapezoids, right? So, now that we figured that out, we need to know what is the big B equals area of trapezoid. One half, add those two, and multiply times the height of the trapezoid, not the height of the prism, alright? So we have to look exactly at one of our trapezoids, and we're going to get all that information from. We're going to get B1, we're going to get B2, and we're going to get the H. So if I look at B1, we can say this is B1. Well, there is no number there, but we know that he is the same as that one right there. So B1 will be 15. B2, well, B2 is the bottom, and we have the number there, so that's B2. And then we look for the height of the trapezoid. We're not looking at this one. No, that's not it. What we're looking for is this one right here. 25.7. So, plug there, and plug there. This will give you your B, your big B. Once you've done that, once you've gone off and you go big B is equal to 1/2, add the two bases, multiply it times the height of the trapezoid. Alright? That's going to give you the big B. Then you can fill in big B times H. This is the H. This will be that. And that will give you your answer. Next question on this homework 7 was number 14. We just did a trapezoid prism. That is exactly what this top part is. So, what you need to do is you need to fulfill this equation. You need to find first that height of your prism. So, look at the prism. Look, it is a trapezoid prism. So the distance between those two bases, that's my height. That ends up being 13. So we already have this one. The other thing is, we need to get this base area. We know it's a trapezoid, so this is going to be 1/2 B1 plus B2. This is a long problem, don't get me wrong, because we have to not only get that volume, we also have to get the volume of the rectangular prism on the bottom. But that one is rather easy, simply because it's a rectangular prism. You just have to do length times width times height. So I'll do it. I'll show you how to do it. But the bottom pieces you should be able to do. All right. So to find the big B, we need to find out B1, B2, and the height. So here we have B1, that's 6. Let's see who B2 is. Well, B2 is right here. That makes it 17. And lastly, we need to find out who the height is. We need to find out this distance right here. Well, guess what? That's what this is for. We know that from here to here is 8 because it's right there. So if this is 8, the whole thing is 22, and that means that that guy has to be 14. 14 is the height of my so this is the volume of the trapezoid. Now, if you want me to follow and finish this, we have the volume of the trapezoid. Now we need the volume of the rectangular prism. Okay? We need length, we need width, and we need height. Length, width, height. Once you get these together, you're simply going to add volume of the trapezoid prism plus the volume of the rectangular prism. Whatever you get there, that's what you add those two together, and you should get that answer. We move to homework 8, problem number 7. I can see why people are questioning this one. Question number 7, well, it's going to require you to use the Pythagorean theorem. So, where shall I begin? You need to get, actually, let's look at the formula. Let's start there. Volume is 1/3 base area times the height of pyramid. So let's look at what they give us. They give us the height. So we already have this right here. We already have, we're missing this piece, but we have 7.2. We need to get this guy, the base area. To get the base area, well, it looks like a rectangle, right? Actually, it's more of a square because it's going to be even all the way through. So, to get the area of any quadrilateral, we need to multiply side times side. We need to find out how much one of these guys are. So we can just find the area. Shouldn't be too hard. We have 90-degree angle here. We have this guy right there. So if I were to just simply connect it, we create a right triangle. 7.2, 9.7, and if I want to know this piece right here, well, that's that piece right there. Pythagorean theorem. Let's move on to the blank side of the board over here. So we'll go with x squared plus, the c is 9.7, so it's plus 7.2 squared equals 9.7 squared. We have that, 9.7 squared. Then we move across. I'm not going to teach you that algebra because you should already know it. We need to subtract. And then we need to square root both sides. X is 6.5. So we end up this piece right here is 6.5, which means that piece right there is also 6.5. So the whole darn thing ends up being 13. Every single side is 13. So if I get the base area, which is side squared, 13 squared. I'll let you plug that in here, which means it goes right there, and then you complete your equation. Okay, let's go to the last problem they asked me to do here. It's really problem 11. Alright, problem 11, let's grab that. Alright, problem 11 is we have to find the volume of that shaded area. That means we have a huge asymptote cone that we need to take away just that empty little cone on top. So it's just finding the volume of the big cone, subtracting the volume of the little cone. I'm not sure if I should work all of it out. We have the big cone here, okay, and then we have the little cone here. So you get the volume of the big cone. Volume of a cone, if you remember, or if you've been looking through your notes, one-third pi radius squared times the height of the cone. So we need two things. We need the heights and we need the radiuses. So let's start with the big cone. The volume of the big cone is 1/3 pi. Let's find out what my radius is for the big cone. That is simple addition, people. Here we have from here to here is 15. From here to here is 10. So my... well, that's radius, and we're going to do height. 25. What is the radius of the big cone? Sorry, I kind of confused you guys, but I went for the height. Now we're going for the radius. Well, here on the big cone, we're looking at 18 as the diameter. That means from here to here is 18, but the radius is half of that. So my radius is 9. 9 squared. Bam. You have your volume of the big. We're just going to rinse repeat this for the small one. One-third pi. Let's get the radius first. Can we find the radius? Of course we can. They gave us this distance right here. That's the diameter, but we already know that half of it has to be 4. Do we know the height of this cone? Of course we do. It's this piece right here. Wait a minute. They have the number right there. Bam. So, you do the rest. We just want this piece right here. Hope you have a good day.